This is GACE O2 theory, problem number 17. Now this is a proof, and since the entire GACE for math right now is multiple choice, you're only going to have to fill in parts of the proof. And so you can see here, this is a very sort of convoluted picture. It looks like you've got some right angles and squares, gives you some sides being the same. Okay, at the end, I want you to notice in the place where you've got to give a reason for, it's saying that two triangles are congruent, and you can see that FAC and BAE, this might be a little confusing because they overlap. And then the last thing is a CPCTC statement about one of the sets of sides of those triangles. Now, we've talked about this in class before, but it is very helpful to separate this picture out. The overlap is what makes it confusing. And so the biggest thing that's kind of hard to figure out at first is, how do I know what to separate out of this? Because this has a lot of stuff going on. And I'm going to tell you, pretty much the conclusion of the proof gives you that information. If you know that the big thing you're going to have to do is figure out that two triangles are congruent, those two triangles are the things you're going to separate out, okay? So you could either go over here and draw something separately called FAC and then BAE, with the understanding, for instance, that you can go ahead, actually, no, you can't. Sorry. I was about to say that you can mark A congruent, but you can't necessarily right away. Okay? Or what I did, and you wouldn't be able to do this on an assessment, but I went ahead and just did an actual copy of it and just deleted out the stuff that I didn't want. Okay? So let's go through these statements and see if we can, and we're going to mark everything. The first thing we know is that ABC is a right triangle. So triangle ABC is a right triangle. That's marked already on there. Also that AFGB and ACDE, that those are both squares. Okay, so let's kind of go through here. If this is a square, so AB is a square. I just marked it there, so I'm going to mark it there. And AF is another side of that square, so I'm marking it the same, both on the square and on both triangles, on the triangle that has it. FG isn't found in any of the triangles. And AB, or GB, excuse me, is not on either of those triangles. Okay, so the fact that FA and AB are congruent, that's because they're both sides of the little square that I just now marked. Okay, and then let's go over here and look at the bigger triangle. Square. If that is a square, then all four of these sides are the same, correct? And let's take a look at this and see. AE is right here. Okay, ED is a side. CD is a side, and AC is a side, which I can mark right there. Okay, so you can see that even though the triangles are sort of confusing when you're looking at them all together, when you separate it out and only mark the sides that you've marked in the overlapped picture, it's a little clearer. It looks like we're getting close to those triangles being congruent. Okay, triangle FAB, and CAE. Let's go back to this square. If this is a square and you were told it is a square, then by definition it has to have four right angles. Okay, same here. All four of these have to have four right angles as well. All right, so it's saying that the next line says FAB, triangle FAB is congruent to triangle CAE because all right angles are congruent. That's true. Okay, so let's take a look at this. The FAB, that's this angle right here. Okay, and the fact that it's congruent to CAE, if you notice, even though the C is not here, that the angle CAE is shown right there. Okay, so you've got a 2 mark, two 90-degree angles, and a 1 mark. Okay, so, and that's because all right angles are congruent. The next one is angle BAC, and if you look at, and I'm going to color this for you, make it smaller. Look at this yellow angle right here. The A angle that is in between there, that's this angle here in yellow. and then it's also this angle here. Can you see that? Okay, and so on the big picture is where you can actually pull the names of the points. And this is angle BAC, and it's congruent to itself, of course, and that's because of the reflexive property of congruence. So note, that and that are the same. So you've got a 90 and a yellow-blue dot, and another 90 and a yellow-blue dot. Okay? Also, angle FAC, then, is congruent to angle BAE. I'm looking at the two smaller triangles now. That means that this angle here and this angle here have to be the same because you're adding the same two angles to get that angle measure. Okay, so if FAC and BAE are congruent, you can now see, and it's real easy to see when they're separated, this is a side angle side property. And then, of course, FC is congruent to BE by CPCTC. So the answer to this is side angle side, and that is B.